The next assignment, we're going to design the swing arm for the bike. So the swing arm is this unit here. It attaches to the frame where it's going to pivot. The wheel is going to attach, the axle is going to go through the swing arm. Your brake caliper would be attached to the swing arm, and then that swing arm would be also be mounted to the frame using a shock absorber. Now this shows a single shock. We'll use a shock absorber on each side. So let's talk about what a swing arm does. So it's this mechanical assembly. There's all kinds of geometries that you can see. We're going to keep it very, very simple, but it allows the rear wheel to pivot. That gives us the suspension for the vehicle. The front of the swing arm is going to be mounted in a bearing or a bushing that allows it to rotate, so it'll pivot around that point. And here again is a single shock, but we'll have two coilover shock absorbers, one on each side of the swing arm. That's going to control the up and down motion. Here's some examples of swing arms for different kinds of bikes. These are primarily for motorcycles, but you can get the idea. So here you can see the pivot. There'll be a shaft that goes through there that allows that to rotate. That's where your axle would attach. Let's see, that would be the pivot. This is a single shock mount. There's your pivot point. Your shock absorbers mount to here. Your axle goes through there, and so forth. Here's one on something similar to what we're building. So you can see it has a small engine here. Here's the swing arm. You can see where it's mounted to these plates that are going to be welded to the frame. In this case, they're using some kind of a bushing, and that's fine. This will allow that to pivot around that point. Typically, we would use like a bronze bushing. You don't want to put steel on steel. And here's your coilover shock absorbers. Here's another viewpoint. Here's a swing arm. There's your rear axle bolt. That's the brake mechanism. There's your drive sprocket, and that's the pivot point for the swing arm. Again, they're using these plates that are welded to the frame. So that's a good design for us to use. Here's a unit without the motor. Again, here's the swing arm. Here's the shock absorbers. There's the pivot point for the swing arm. And that's the jack shaft. We'll talk about that jack shaft in a little while. So here's a good process for you to do that. First of all, take all the components that make up the rear wheel assembly and create an assembly model for that. Then put it on a drawing sheet. What you can do then is add dimensions. So you can use those dimensions to help you design your swing arm. And you might just want to start by printing it out and making a sketch, creating some concepts that you think will work. Then you're going to make a model of the swing arm. Now eventually we'll have to do detailed drawings for each of the parts that go into the swing arm. For now, if you want to just make it as a single unit, that's fine. We can come back for that. Add a swing arm to the rear wheel assembly, and then you may have to revise it as you go so everything fits together. So here's an example. What I did was I assembled everything: the wheel, the tire, the rear hub. There's a keyway that runs the entire length, and you're not going to know the length of the keyway or the length of the axle, so you can make them extra long, and then you can just edit them as you go to make them fit. It's got the brake caliper and the caliper and the brake rotor. Now you want to keep the hub on the outside so you'll be able to tighten down those set screws. And I've got my sprocket and my sprocket hub. Here's some bearings. There's my axle. It's threaded on the ends. So with that in mind, those are parts you should already have models for most of those, with the exception of the bearing. And I'll show you how to do that. Here's an exploded view. Again, you can see all the pieces, and every one of those is a commercial part. So I took my little sub-assembly of the wheel and with everything on it, and I put it onto a drawing sheet, and I did an orthographic view because I wanted to put some dimensions on here just to have some working dimensions. Now, this design is not the same as yours. This has got a small tire. Your dimensions are going to be very different. And then one thing I want to try to do is minimize the space here. Don't make this assembly too wide. Here's the bearing on one side. Here's the bearing on the other side. Right now I've got like 8.5 inches inside there, and that's perfect for the size of this bike. Think about your motor up here. How wide is your motor? How wide is your frame going to be? Your swing arm shouldn't be much wider than your frame, so pay attention to that. Now, stuff can't be touching. Obviously, I have to be able to put a chain on there, so I've left myself 3/8 of an inch between the tire. You have to have clearance for your brake caliper. I left 3/8 of an inch there, and that's about as close as you're going to be able to get. And just some other general dimensions, because ultimately you're going to have to create a bracket to mount your caliper and so forth. And so you can see I'll be able to create a mounting system where I can attach these bearings to, and that's kind of what you're looking for. Also, when you design the swing arm, you want to make it fit with the size of the tire too. Don't make it too long, it's going to look weird on your vehicle. Should be kind of a short vehicle, so don't leave a ton of space between there. So this distance, as I said, is pretty important. That's what you want to figure out. So what I did was on my assembly model, just kind of bumped the parts in and out. I put some work planes on there and constrained the sprocket and the brake. And I tried to get these close within reason. You shouldn't have inches, you shouldn't have 2 inches or something between all those, because this ends up being really, really wide. And then you got a bunch of empty space in there that doesn't make any sense. So one thing I said was look at the width of the motor. If you take the motor with the CVT on it and see how wide it is, that's kind of a good ballpark number for your width. Obviously, it doesn't have to be exactly the same. So once I had that drawing, I started designing my swing arm. Again, pay attention to the width. I started by sketching my ideas onto the drawing. And then I kind of refined it to try to fit the pieces together. It's going to take some revision, so make a model, go back and edit it. It's part of the process here. And make all your components, if it's the swing arm, use round tubing. If you have like plates to mount the bearings to and so forth, just use flat stock for that. Then I created a sub-assembly of the swing arm, and then I attach everything together. And again, I had to revise several times to get to the point where I was comfortable with how the swing arm looked and how everything fit together. So again, you're not going to get it right the first time. Here's some examples of swing arm designs that I tried. Now here, what I did was I looked at the bearings and tried to build it around the bearings. So here I just went on to a manufacturer's catalog and found some flat 2-hole bearings at 1-inch ID. And then I made some plates to mount those two. And then I made some tubing and connected them to this plate. Now that's going to be attached to your frame, and that's where it's going to pivot. So I've got some bronze bushings in there. That, I don't know, it's a little too industrial looking. I tried this with using these pillow block bearings where I mounted them to the top of the frame. Again, the axle would go through there. I don't really like that too much on this bike. It's a little bit too big. I do like this probably best of all. There's some very compact 2-hole bearings, and they're not too big, they're not too thick, and they work very, very nicely. So I kind of like this design a lot. And here's a different design of the swing arm itself. And I tried using these rod bearings, rod ends, and I made these parts that I fit inside the tube, and they're threaded. But after I thought about that, it's not really smart because these aren't designed for continuous rotation, so those would wear out very quickly. So that's not a great design. I think I'm kind of leaning toward this design right here. So here I ended up with my sub-assembly of again, the rear wheel with all the parts on it, and then here's my swing arm. It's got a bearing on there, and you can see everything's kind of compact looking. That's what we're going for. This bike is going to be short. Don't make this too long. I used that's 1-inch tubing there to make this, and the parts are kind of compact and all fit together. And I designed these plates that the bearings are mounted to. I designed them so it fits nice and neat. You don't have a lot of metal just hanging on to the back of the vehicle.